Okay, so let's now apply the equations of motion for a particular type of frame of reference, which is the rectangular coordinate system. Of course, this frame of reference must be an inertial reference frame. So whenever a particle or a body moves relative to an inertial which is x, inertial frame x, y, z, reference frame, the forces and the acceleration of the particle can be expressed in terms of I, J, K. And applying the equation of motion, which is summation of F is equals to ma for this particular type of reference frame, we now have a special form which is specific to that frame, which is the sum of forces along x, the sum of forces along y, the sum of forces along z, which is equals to, of course, the mass of an object or a particle and the vector sum of its acceleration along y, x, acceleration along y, and acceleration along z. Of course, our rectangular system may look like this. Depends on the right hand rule. Example, this is our object which moves in this particular trajectory. This would be the x and y, z position. This must be x, this must be z, and this must be y. And of course, the forces x may have a very different direction. This must be f, example f x, f y, and f z. Okay, so for this motion to be satisfied, the respective components, the I, J, K components on the left side of the equation must be equal to the respective components at the right side of the equation, so that we may write individually or scalarly sum of fx is equals to m ax, sum of fy is equals to m ay, sum of fc is equals to m a z. Okay, and in particular, if the particle is only constrained to move along the xy plane, then the first two equations of motion will only be used.